We are surrounded by numbers in our daily life. From the morning we get up till the night we are in bed. And some mathematical wizards even dream about numbers in their sleep. These numbers have become an integral part of our lives. We have conversations like, "It's already 4. I'll have quarter cup of milk in my tea. 2 eggs for my breakfast please," so on and so forth. One thing that you may have noticed that is common in these conversations are, yes, the numbers. 4, quarter, 2 are all numbers. Let us try to understand these numbers. The numbers that we commonly use in our day-to-day life start with 1 and have no end. Any numbers that we talk or discuss are made up of digits 1, 2, 3, 4 till 9. Right? No, it's actually wrong. There's one more digit to this list, and it is quite an important one. Yes, it is 0. It is an Indian invention to the world. Without this 0, any number space would have been limited only to numbers 1 to 9. And existence of the topic that we will be discussing now would be highly debatable. The numbers that we use in our daily life are classified into different groups called as number systems. The first set is called the natural numbers. They are denoted by the letter N and contain the numbers 1, 2, 3, 4 and so on. When you add 0 to the set of natural numbers, we get whole numbers. The whole numbers are denoted by letter W and they contain the numbers 0, 1, 2, 3, 4 and so on. Whole numbers can also be defined as non-negative counting numbers. The next set is called integers. This set contains natural numbers including their negatives. Its symbol is Z. The set of Z contains all negative counting numbers, 0 and all non-negative counting numbers. The ratio of an integer and another non-zero integer forms the set of rational numbers. These numbers are denoted by letter Q. -10, -5.2, 0, 1.75, 25 and a quarter are some examples of these rational numbers. There are some numbers which cannot be described as complete fractions. For example, under root of 2, under root of 8, epsilon, pi, etc. These numbers are called as irrational numbers. The next set is called the set of real numbers. It is denoted by the letter R. This set is the union of all the rational numbers and the irrational numbers. Example of real numbers are -100, -50.25, -8 and a quarter, 0, under root of 2, pi, 5.8, 30 and so on. The number line of real numbers consists of all the real numbers arranged in ascending order, starting from negative numbers and going towards positive numbers. We will study this in detail shortly. Like real numbers, there are imaginary numbers. The square of an imaginary number is a negative real number. Imaginary number is accompanied by letter I, which stands for square root of -1. The examples of imaginary numbers are I5, I10.25, I under root 2, -7.5i, etc. The next set is complex number set. The complex number is formed of two parts. It has a real part and an imaginary part, and it is expressed generally in the form a plus ib, where I stands for the imaginary part. Examples are 7 plus 2i, 10.5 minus 80i, minus 15 plus 8i, and so on. The Venn diagram shown here will discuss the number system that we have discussed just now. As we can see, the natural number is a subset of integers. These integers are a subset of rational numbers. The set of irrational numbers forms an altogether completely different set. The set of rational and irrational numbers gives us the set of real numbers. Again, we have a different set of imaginary numbers. The combination of real numbers and imaginary numbers will give us the complex numbers. The next topic that we will discuss is the number line. The number line is a straight horizontal line on which the real numbers are arranged in ascending fashion from left to right. Every point on this line corresponds to a real number. In the line shown in the figure, we can see the integers from -4 to 4. However, the line contains all real numbers continuing in both the directions. This real number line helps as an aid in teaching and understanding mathematical operations, especially the ones involving negative numbers. The center of this line is denoted by 0. The positive numbers lie on the right hand side of the 0, whereas the negative numbers lie on its left. A number on the right hand side is greater than any number on its left. Let us see examples to place some given numbers on this real number line. We will try to place the following numbers: -8 1/4, 5, 0 and 10.5. -8 1/4 lies between -8 and -9. It lies at a quarter point away from -8 towards its left. The point 5 lies at a distance of 5 places from 0 on the right hand side. 0, as we all know, lies on the center of the real number line. 10.5 will lie midway between 10 and 11. Let us discuss how mathematical operations can be studied using this real number line. Try adding 5 and 3.8. Starting from 0, draw a line till 5. Now draw another line till 3.8 from 0. Place the start of the second line at the end of first line, that is at 5. Now measure the point where the second line ends. Point is 8.8. This is the answer of addition of 5 and 3.8. Let us perform 2 minus 8.5. Draw first line from 0 towards 2. Draw next line from 0 towards minus 8.5. Both these lines face opposite directions. Place the second line's starting point at the end of first line, that is 2. Now measure the point on number line where the second line ends. The point is minus 6.5. This is the solution of problem of 2 minus 8.5. Similarly, any other such mathematical operation involving real numbers can be performed using the aid of real number line. Thank you for watching this video. I hope you learned something new or revised the learned topics. Stay calm and keep learning.